So good afternoon, all dear participants. Today is the first session is given by Dr. Animesh Dayal sir. Sir is a founder and the director of CodeMed IT Services Nagpur. Sir has completed their PhD in Computer Science and Engineering in Natural Language Processing. Sir has completed their post-graduation in Wireless Communication and Computing. Sir has graduated in Computer Technology. So, sir has a vast experience of 20 years in technical training experience, then 2 years in industry, like Philips semiconductor industry in Bangalore. Then, sir has published near about 43 papers, 43 research publications in international and national conferences and journal also. Sir has 2 times Best Paper Awards nominated as a Best Paper Awards. Then Sir is also a member of international professional bodies like ACM and IEEE. Sir as a co-com member of IEEE for 4 year consecutive 4 years, 18 to 2022. Sir is also IEEE senior members 2021 onwards. So this is all about the today's experts, Dr. Animesh Dayal sir. So I request Animesh Dayal sir to please give informative sessions to dear participants, and session is hand over to you, sir.
Thank you so much for nice introduction.
Thank you, sir.
Yes. So good afternoon, all dear participants. Today we are discussing about the natural language processing and its library. I think it's the last day of this FDP. So in last days, you have learned so many machine learning algorithms and deep learning algorithms, means involvement of AI in different healthcare research. So in today's session, we will discuss about only one prominent area of the healthcare in AI technology. Means we will explore some clinical text analysis using natural language processing. So might be all of you definitely aware with the natural language processing. I will give the brief introduction of natural language processing first. Which kind of libraries will be used for processing the data in natural language? What are the different steps we have to follow when we are doing the natural language processing for any kind of data, not only clinical? And then we will be the hands-on on some library. So आज का session सिर्फ theoretical नहीं है. It will be the definitely hands-on to you. So I request to all of you, please be ready with your laptop or computer with some Colab library of Google. We will do all the hands-on in Colab. So if anybody is unaware regarding the Colab, so he or she can raise your hand. I will just in 5 minutes I will explain Colab also. So anyone, please, if you are unaware regarding Colab, then only. So might be all of you are aware with the Colabs. Okay, thank you. So now I'm first give you the brief introduction of today's topic. What are the dependencies? What are the limitations? And then directly we will go through some hands-on session. Okay, I'm sharing my screen. एक second. Is it visible to all of you?
Yes, the screen is visible.
Okay. So this is the today's topic, natural language processing, NLP in the clinical text analysis. So first, what are the NLP? How can we use the NLP on which areas? So it's a very prominent and important field of artificial intelligence. If we are learning artificial intelligence, data science, so it's a important part of any data science algorithm. Means all kind of you can say algorithms of machine learning and deep learning also needs some data processing, data pre-processing, data cleaning, everything it is needed. So the in this case, natural language processing in the sense, you know, the processing means you are derivating some datas, you are parsing some datas, and after the parsings, there are the different types of steps, different types of cleanings, different types of tags are available. And we are using POS tagger by default. In maximum cases, there are different taggers are available, but some prominent taggers are OpenNLP and POS taggers are available. So we will use all these taggers in our hands-on session. So it is the text processing is the main application of NLP. Name entity recognition is needed in clinical data analysis also. Sentiment analysis, topic modeling, and machine translation. Why clinical data matters? Clinical data means it's a different type of data. Means you can say हेल्थ रिकॉर्ड हो सकता है. इट मे बी कि क्लिनिकल डेटा में आप कंसिडर कर सकते हो कि किसी पैथोलॉजी लैब का रिपोर्ट है. इट मे बी कि सम हॉस्पिटल्स के रिकमेंडेशंस हैं आफ्टर हॉस्पिटल व्हेन पेशेंट्स आर डिस्चार्ज. तो डिस्चार्ज कार्ड is available with the patients, and discharge card having the some recommendations of the doctors, the complete summary of that patient during the hospitalization is available on this card. Correct. Doctors note is the main challenge. The language use different types of doctors are not the language is not standard. Different doctors, different specialization, they are using different types of language. So everything should be interpreted by the machine. Lab reports and imaging. Medical imaging means different types of images हैं, sonography है, x-rays हैं, correct. So different types of imaging reports are also available, and all these are the matters which the in which the patient information is available. So the challenge is the big challenge is unstructured data. Format is totally unstructured, so the processing part will be the need more cleaning and more tagging about the words. Name entity relationship is most important thing to process. In between, we should represent what is the diagnosed by the doctor, what are the chemicals, what are the medicines, where the medicines exist. So everything should be understood by the machine. And the complexity data volume means for the one patient, there are the complete files are available for the single patient. So the volume is large. The complete medical history of that patient during hospitalization, during the complete lab reports, correct. And different labs are having the different formats of their reports. They are not no some standard report format also. NLP applications in healthcare. The most important is, as I say, information extraction, patient outcome predictions. So information extractions means disease, medications, and treatments. Everything is available in a single paragraph. Sometimes when the doctor's reports are available, or some pathology reports are available, so everything is available in a single paragraph. In between, there are a number of verbs, nouns, and adjectives, uh, stopping words, and you can say different types of words and different types of tags are available. So we need to clean our data, and we need to differentiate what is the disease, what is the medications, and what are the suggested treatments. Same is patient outcome predictions, means analyzing patient record to predict health outcomes. This is also challenging. And clinical decision report supports the summarizing the patient histories for better decision making, research advantages, sorry, advancements, and that's all. These are the some different applications of NLP in healthcare. So these are the main techniques which are using by the natural language processing with different libraries for healthcare. Means the most important thing is tokenization and lemmatization. This is the most important thing when for cleaning the data. The second important is name entity recognition, NER. After that, sentiment analysis also can be used in some cases. Text classification, word embedding. For word embedding, we can use word2vec or BERT libraries. Topic modeling using LDA. So we will explore out of these at least 1, 2, 3, some kind of techniques we will use in today's session in hands-on. Challenges and solutions. Data privacy is the big challenge because in maximum case nobody will share data with you for the research purpose. Doctors also have some means you can say reservedness to share the data of the patients, and patient also not interested to share the data. So, and after sharing, when we process the data, so the challenges is the data should be private to the particular patient and doctors. Second challenge is means the data is completely unstructured, so it's in need of advanced parsing algorithms. We need to derivate data, and we need to identify which data is useful for us. Another is domain specific language है, that means UMLs हैं, medical ontologies हैं. So these are the different specific languages. We are talking about the English language only. In some other states, the different languages also is a big challenge. And data imbalance. Augmentation is the big problem, big challenge. And we can do this using the NLP libraries. We will use some libraries here. The applications are these are the different applications which are analysis, clinical trial matching, it identifying the eligible patients using NLP, disease surveillance. These are the different real world applications for the text analysis. So this is important. We should know about the some libraries and languages which will be useful for NLP, natural language processing in healthcare. So programming language, as we know, this is Python or R. R is not recommended right now, but previously R was the first language to recognize all the data and data analytics using R. But all the Python libraries are more than sufficient to do the all kind of analysis right now. Now, which libraries we will be using? These are the different libraries for Python. First is Specie, and the second one is the most important one, Specie. Science Specie. Correct? The full form is Science Specie. Specie is the improved version of NLTK. So previously, NLTK is the only library for natural language toolkit, natural language processing purpose. For natural language processing purpose, NLTK is the only library, but Spacey is the improved version of NLTK. And now, specifically, if we can say, Spacey is the specialized version of Spacey for science specific data analysis. Means medical science, yeah, any other science specific, means it is a more improved more improved library or framework for the this kind of healthcare analysis. So we will use both Spacey and Spacey. Some models are already available in Spacey library. So we will use directly and we will do our work. प्लेन स्पेसी भी यूज करके आप हम लोग आज चेक करेंगे प्लेन स्पेसी से हम किस टाइप का डेटा कर सकते हैं एंड साइज स्पेसी इज आल्सो demonstrate. We will not use NLTK because if you are using Spacey and there is no need to use NLTK, but we know NLTK is also the available library of Python for NLP purpose. Scikit-learn and TensorFlow, these are the library of Python, but not used for the NLP purpose. These are for machine learning and deep learning purpose. And because the all the fields are related, connected to each other, NLP is also used some in projects of machine learning and deep learning. So these are the most important libraries of for processing the data. If we want to generate the models using some machine learning algorithm and deep learning algorithm, if the work based on the images, so we need to go with deep learning, CNN, RNN, everything. So all are the dependent. And this one is also healthcare specific tools. These are the tools, not library, but we will use size specific library for healthcare purpose. You can ask any question during presentation also. Okay. These are the implementation level. Means these are the everyone knows these are the theoretical things. We will not discuss. You can read out. This is not important one, so that we will go through the directly hands-on session first. These are the terms which are used in different types of reports. You know, heart rate, repository, respiratory rate, and temperatures, everything, laboratory test results, blood test. Correct. These are the terms which are used in any lab reports or clinical reports. Diagnosis, treatment, correct. Hospitalization. They are the words, terms using in any kind of reports. So ethics, the most important word, ethics. In these words, we should know about the ethics in clinical data analysis. सबसे important है data privacy and security. If someone believes you, or we are the developer, we are the service provider, things, so we need to ensure that data should be private and the security should be it should not be shared with anyone. Avoiding biases in the algorithm training, maintaining transparency in AI-driven decision. Transparency is also an important factor. Ethics, ensuring data privacy and everything, and another things also. Emerging trends, that is integration with wearable devices for real-time data. Means wearable devices means you can say there are the different body sensors are available in healthcare, which continuously check your data, check your suppose O2 level, suppose your heart rate, everything is in some cases means when the patient is in ICU. These all are things are attached with the patient, and this is called wearable devices. to identify the real-time data, and that data should be uh, analyzed by the real-time analysis is required so that predictions will be the proper. Advancement in explainable AI for healthcare, yes, emerging trends, you can say. Use of multilingual model for the global healthcare, yes, this is the research area. You can go with this. Multilingual means the we are talking about the English reports in English language. In India also, there are the different types of languages are available. So doctors prefers some local languages in maximum case. When local languages are used, so this is another challenge. So this is all about the basic introduction. Now we can go through the hands-on only. So I request to all of you, so please open your NLP, means your collab. I have prepared some complete file for you, and I will share all the codes with you one by one, but you need to follow all the instructions. तो आप लोग साथ में करेंगे तो डेफिनेटली आप लोगों को इसका हैंड्स ऑन प्रैक्टिस अच्छे से होगा. And some data I will share in I think we can share is in a chat box, this thing. Okay, so I will share here in messaging. You can copy the commands and you can directly use. So please, all of you, please open your Collab notebook first. Okay, so this is a simple example of specie. So what we can do, just specie, how to use specie, just go through that. And I have another one more particular examples for the basically clinical text. This is based on the simple text. Why, how specie work, how the tokenization limitations are available, how it is done. वो जस्ट यहाँ पे हम एक बार चेक करते हैं, देखते हैं. एंड देन आई विल पहले ये फाइल्स का भी आपको पूरा डिटेल्स हम डिस्कस करेंगे. एंड देन आई विल स्पेसिफिकली हम किसी पर्टिकुलर रिपोर्ट का एनालिसिस करेंगे. ओके, तो फर्स्ट आई नीड टू इंस्टॉल specie using pip command. All of you might be definitely know. So pip install specie. So after this you can yes, I might be all of you have connected in collab work. So can you raise your hand who are already connected? Okay, Vyas, Mr. Vyas. Any other? So rest of all, please connect and just notify me you have connected with your collab notebook so that I can start. So kindly raise your hand who are connected with the collab? Is there any problem to connect with collab? Any issue? If you have any doubt, you can ask. No one is connected collab. So how can you do the, if you are facing some problem, you can ask to connect how the collab should be connected. Okay. Sir, shall I continue? Dheeraj sir, because no one is replying.
Yes, sir. You continue.
Okay. Yes. Anyone else? Okay. So this is our this is a file in which I have prepared some examples regarding the specie. First, we need to complete specie installation. After that, these are the commands. These are not the commands. These are the logics. We need to import the specie after installation. After installation, we need to install specie. After that, we need a NLP specie.blank. Its language, it represent language, en, and then we will continue the specific modules, that is doc. Doc is used NLP, and this is a single sentence which need to be parsed, which need to be tokenized, which need to be lemmatized. So we will use directly tokens, pure stagger we are using here, correct? Open NLP for token in doc. Doc is stored in this kind of single sentence. So print tokens. So these are the tokens of this sentence. These are the different tokens. So the complete sentence is divided into some tokens, including the stop, that is called punctuation mark. Then after that, one more sentences I have given to this thing, and in this case, the command is different. Dot sends and the print the sends. So it complete the sentences that depending upon the punctuation mark, it will separate out the sentences also. So these are the two sentences. So it complete it means it is divided into two lines sentences. Then again POS tagging. In POS tagging, suppose this is a sentence in which this is the first sentence, my name is Animesh. The second sentence is longer than the first one, and we are applying for the POS tagging token.text. So my is the pronoun, name is the noun, is the auxiliary words, Animesh is the pronoun, punctuation marks, everything will be tokenized here, and including space also. Space between the after punctuation, there will be the space, and then it is complete. Yes, this is also one space after signs. So this is called tokenization using the POS tagger. Every word have some kind of tags. So the text is important, and in the complete sentence, there are the certain verbs which are using enjoy, writing, and going. Then the lemmatization. Lemmatization is the very important one. It works on the maximum case helping verbs. In helping verbs, you can see if the sentence is this, and there is a helping verb like is. Otherwise, the particular token and token lemma will be the same. Suppose in this case, first my is the token and the lemma is also token. Name is the token noun and the lemma is also name. But in the case of helping verb, is a token, but the lemma is the B. Similarly, you can see writing is a token and write is the lemma. So where's the helping verbs are using, and some tenses and ing removing kind of things, we can use directly verb. Write is a verb. तो वर्ब के साथ जितने भी पंक्चुएशंस एंड हेल्पिंग वर्ब्स के साथ जो भी लगा रहता है उन सबको रिमूव करने के लिए लीमा इज मोस्ट इम्पोर्टेंट. लाइक दिस, इट्स आर्टिकल्स and the lemma is article, correct? Similarly, you can see going. Yes, it's a going, and after that, what is the lemma of going? Lemma of going is go is a proper lemma. Then similarly, we are not using here size specie, we are using here simple specie particular library, and the sentences are not clinical, sentences are simple completely, correct? Then name entity recognitions will be used, and in that case you can see it converts the complete paragraph. This paragraph is related to the name, like my name is Ram, I enjoy writing. So I is connected with the Ram, correct? So I is connected with the Ram, and my everything is the connected. So this is the relationship. Like articles on LinkedIn, check out my others articles by going to the profile sections. So it divides the complete name are used, nouns are used, pronouns are used, and it's the different entity recognitions. These are the different entities. So here the print is the stop word. Yes, it's true. It give the also here some stop words. We can ask, the answer will be either true or false, correct? We can visualize also dependencies and entities using specie. To visualize all dependencies and entities, we can use directly, these are the kind of rendering we can use. So this kind of graph, it's not completely visible. I hope, yes. It's a big graph according to your sentences. The complete sentences is divided into the leaf nodes, root nodes, and parent nodes. So this is the dependency graph basically. So we can see name is connected with the my, is connected with the name, is also connected with the RAM. So auxiliary, name, tagging, everything is available here in this image. So this is called visualization of dependencies. Correct? Might be all of you know about the dependency graph. So this is the kind of dependency graph. Okay. So the last we can say yes, text, the complete you can say for token. This is the text basically. So in this text, we are applying this kind of different specifications. Text, lemmas, POS tags, dependencies, correct? Everything is available. Is alpha? Yes, true. Is stop word? Yes, true. Correct. So these are the different kind of analysis based on the given text. Now, phrase matching is also done using, you can say, the spatial library. Phrase matching also possible. Like I enjoy working on natural language processing and machine learning projects. It's a simple sentence. And the phrase matching is match phrase, you can say natural language processing, and the match phrase is machine learning. So natural language processing and machine learning is the matching, phrase matching output. Correct? You enjoy working with both, means the natural language processing and working with machine learning projects. So this is called phrase matching. Word vector similarities. For word vector similarities, you need to download this framework. You can say patch en core web md. This is the patch for is available in this PC. If you download and install this, then you can use directly. Correct? So for this example, dog one is dog, cat, dog, and car. So what is the similarities? Cat and dog having the similarities of this kind of factors. But cat and car, whether the spellings are approximate same, T and R is different, but the properties of these things are not same. So according to properties, it will be the reproducing the similarities. Custom name entity recognition. Name entity recognitions is the most important task required in clinical data analytics. So this is important one available in SPACY library. Here the sentence is different. The Eiffel Tower is in Paris. So entity is the Eiffel Tower. Label is FAC. And the entity is Paris. Label is GPE. What is FAC and GPE? You can identify. So this is the different functionalities provided by the SPACY library. Now we can go with I think some. Okay. Anybody ask something? Good afternoon. Okay. Fine. So we can go with another notebook, Collab notebook, Python notebook that is for specifically designed for you clinical text analysis. Correct. So in clinical text analysis, as I said, there is a specific library that is SciSpaCy. SciSpaCy we will use including with the so all the features of SpaCy is also available in SciSpaCy, including some other models also. All models are available in SciSpaCy also. So one by one, I am giving you the instructions. You can go through that. Anybody require code means or otherwise I can explain only because I think आपको ने अभी तक link, please share to share code. Okay, I will give you main important codes in here. You can copy paste. Okay, fine. Rajasmita Panda. I will message required code, like means the libraries which you need. So definitely I will share. So the first is, our aim is to extract clinical entities like disease, medications, correct, process, and their relationship from medical text using SPECI. So in this case, we need to install these libraries. First SPECI, second is SciSPECI, and these are the two different models which are available with the SciSPECI. And you need to install this SciSPECI model, which will help us to analyze the clinical data. So I am sharing these all 4 commands you need to run, and it will take time if you are doing parallelly. So it needs you. So I am sharing these. You can copy paste directly. These installations are required. You need to install SPECI, SciSPECI, and these 2 different models available. So please, once you install this, then I can go ahead. It needs time, about 2-3 minutes. Time is required. These 2 models I have explained here. Yes, some kind of errors are also displayed, but don't worry, it's just warning, and it's dependency related. So आ भी सकती है, नहीं भी आ सकती है, depends. These are the 2 different models we are already installed. First one is a small general purpose scientific model. The general purpose scientific model is available with us. We had installed, and the model specializes detecting biomedical entities like disease and chemicals. So these 2 models are already we had given the instructions in first command. This one. These are the 2 different models. Okay. So please message. Yes, you can message me when it is installed. Installation on. Okay. All of you, please participate in discussions. Then only the purpose of FDP will be fulfilled. Yes, anybody else? और किसी का installation start हुआ है, complete हुआ है, so you can message, or you can unmute also. You can talk with me. Okay, till that मैं यहाँ पे next command लिख देता हूँ. So the next command is for input. This is for loading the models. After installation the libraries, we need to load the models, and we need to import SPECI, and then after that we need to load both the models which we had installed. So this is the code for दोनों models में हमने different variables लिए हैं. This is the NLP and this is NER. Okay, the next instruction will be here. We need to do this. Directly you can copy paste. Code will be definitely running because I have tried this lots of time. Only one person responded, Rajasmita Panda. Yes, installation done, Rajasmita. Okay. So you need to install, you need to load the models also. Once you're done, then I can go ahead. Installation is depends on your internet speed also. The size of file is not too big. It's hardly 15-20 MBs, but it needs, if the internet speed is good, definitely you will be doing fast. Okay. So the next, after this, this kind of output you can show. Next is input clinical data. This is the important one. You need to input clinical text, which need to be analyzed. So I have different kind of text. I will share with you. This text is called the patient was admitted with acute. Means this text, I think punctuation. Yes, yes, yes. मैं इसको ब्रेक कर देता हूँ पे. हाँ. Yes. So this is the discharge summary. Follow up in cardiology clinic is advised in 4 weeks. Yes, this is a discharge summary of some patient. Okay. So okay, in first round we will do this. So I have some clinical text here. I will share with you. Suppose the first one is the patient was diagnosed with type 2 diabetes, है ना. इसको करते हैं. Let's see. Okay, we will change the text. Okay. That 2 lines data. The patient was diagnosed with type 2 diabetes. Type 2 diabetes. Okay, and he started the metformin 500 mg. Means it is a medicine twice daily. Okay. There is a past medical history of hypertension managed with some clinical term. I don't know. Amlodipine 10 mg. Okay, this is also medicines. Okay, fine. So I also need to run chat. Maybe I need to be connect. So you need to run Rajasmita first. Installation is not completed. Is maybe according to your error message. फर्स्ट इंस्टॉलेशन आप फिर से एक बार चलाओ एंड देन लोड करो. लोड करने में प्रॉब्लम है. एंड सेकंड वन मींस दिस इज नॉट allowed. So installation is not proper. pip install command you can run again. Yes, Mr. Mital Dhoni. Yes. Any doubt? Yes, Mittal Dodi, you raise your hand. So any doubt? Okay, no doubt. After loading इजीली लोड हो जाएगा आप में आई थिंक आपका इंस्टॉलेशन प्रॉपर नहीं हुआ है सम प्रॉब्लम्स आर देयर बट लेट्स सी मैं अभी चलाता हूँ ओके द सेम you got also so okay I need to install this again installation is required this package needs time nms library Rajasmita, I am also doing the installation once it is done I will check yes we are installing the first command I had mentioned here these are the first required libraries, specie, size specie, and these are the two different models which are using in the hands-on. So these two models we are installing currently. Okay, I will paste it again. Or I will pin it also. The path is right. No, I don't know. Links needs access. Which access? Okay, okay. You are talking about the feedback link. Sorry. Okay. Yes, this is the text which will be used. But okay, thank you. So yes, it is completed. The installation is completed. So I need to load the models. Yes, successfully models are loading. Yes, it is done. Yes, Rajasmita, you can see. So once the installation is completed, then only you will load the model, and model is already done. Now you can input the clinical text data. In this case, you need to create the variables. I will again share this particular command in window. Okay, correct. We had created clinical underscore text variable to store this clinical text data, and then we will process it. Okay, how can we process the text? For processing the text, these are the command you can run. For processing the text, so we are doing here a tokenization and POS tagging. You can see here tokenization and PO part of speech tagging here. Correct. So after that, I will run this. After that, we will run this. Yes, both are correct. So the data is divided into the tags. Correct. The space that determine. Correct. Patient is the noun. Correct. So these are the kind of tokenization and POS tagging output. Okay. After this, we need NER means named entity recognition for this text. So this is the instruction. Okay. So this is the next instruction for the NER specific task. So Rajasmita, you have done all these things. Yes, complete. Name entity relationship is also means diabetes and mellitus. These are the disease, correct? Metformin is the chemical, means it is a you can say medicines. Hypertension is a disease, and this medicine is also recognized as a chemical. Okay, fine. So this is the output of named entities using specie. After that, we need to analyze relationship and patterns. Correct. Dependency passing relationships. We are not plotting here dependency passing dependency graph. We are just identify what is the relationship between the different tags. So this is a code for identifying the dependencies. Okay. Loading again will take time. Please proceed. Okay. Okay, Rajasmita. So this is the coding part. Dependency relationship. So the output of this I can see. Yes, again I had implement this code, and the output is this. Next is uh, entities with disease and drugs need to be linked. All the entities with disease and drugs. So you can extract entities and map relationship using rule-based approach. There are the different types of approach. We are using here the rule-based approach and or custom models. For example, you can see these are the disease and these are the chemicals related data. I will share this one also, and after that I will run it. Okay. I'm sharing any other else, और कोई है जो साथ में कंटिन्यू कोडिंग कर रहा है? I can wait if you have some doubts. So after this linking, we can see these are the disease completely. There are two different disease are reflected in the text: diabetes, hypertension, and the medications means chemicals, metformin and whatever amlodipine. Okay. तो आज के दिन यहाँ तक हो गया आपका आई थिंक print statement is incomplete. Print statement is incomplete. You can unmute also. Okay, so linking is also done, and then expand with custom pipelines means ये हमारे data को और properly explain करने के लिए, correct? So which are the entities and which are the, so we had done the pre-processing, tokenization, lemmatization, and NER, named entity relationships. Correct. The now the data is completely, you can say, tagged in the different type of entities. Correct. Now you can use these entities in the different type of analysis. Yes. So I will share this one also. This is the last one, and I will change the text after this. And our model, which is designed for this purpose. Yes, Mr. Sen.
Hello, sir. Can you hear me?
Yes.
The last print statement is actually incomplete. So there is the statement I can read, like medication token text is related to this, and which is disease up to related disease, right? That section is not there. So it's not showing single cell. Okay.
Yes, you can see the pointer. This one.
Yeah, that one. But that last statement, print.
This one.
Last. No.
This
In
one.
the coding part. Yeah. This statement I mean.
Yeah. In this statement, what is the problem? Not showing.
This statement I need. Actually,
Okay.
the copy paste section is incomplete. Yeah.
Okay, I forget maybe. Okay. Now okay.
Yes, sir. I am following you, sir.
Okay, great. Thank you so much. So after this, you can get this kind of disease and medications. These are the different. Disease are different and medications are different. And this one is the last one. Now we can change the data. Suppose this is the diagnose and medication data. Lab result data are different. The format of lab result data is observations, correct? Or different. Hospital discharge summary is different, correct? Chief complaint, yes, this is the another kind of medical data. "62 years old female presented with the complaints shortness of breath or exertion, correct? And occasional chest pain over the past 2 weeks. She denies any fever, palpitations, or recent illness. This is not, there is no medications, nothing. So let's try this data. What kind of analysis will be done by the SPC or NLP? Okay, we will change only our data, clinical text. We will copy paste here, and we can run directly. Okay, so now we need to run this again so that the data is stored in clinical text. After that, all the instructions need to be done. Process the data, yes. Female entity, complaint is the entity. These are the different entities. Okay, good. And these are the tags. 62-year-old is the adjectives. These are the dash. Female is a noun. Okay. Name entity relationship is, yes. So all these are the disease. There is no medications in this clinical text. Okay. So complaint of shortness of breath, this is the disease. Chest pain is a disease. Fever is a disease. Correct. Palpitations is the disease. Now we can do dependency parsing also. This is the dependency parsing, and then linking the entities and disease and drugs. Drugs तो available ही नहीं है. So let's see. Yes, the array is empty. This array is empty. Medications is only, disease is analyzed by the natural language processing. Great. So our model is working with all kind of different data. So I have lots of data here. So suppose surgical procedure note, correct? And medication side effects. Okay, let's try this medication side effect in our model. I can share the complete model, the complete code with you. If you require, you can message me in the chat box. Yes.
Sir, the entire thing I have done and it's working, sir. I can try out with other text if you consider it.
So can I share the different clinical text data with you?
Yes, sir, please.
Okay, great. Fine, sending here this data also. This is a kind of medication side effects, correct? So you can try this also.
Yeah, sure.
So I'm also trying. So just I stored it in the clinical text. Then yes, process the text. We also done. Very nice. Now NER, applying NER, name entities. Yes. So nausea is the disease. Dizziness is the disease. After the medication side effects, correct? Nausea, disease, and the name of the tablet, I think, hypertension, and this is also chemical. So once you read the this particular, yes, the patient reported persistent nausea and dizziness after the starting. Yes, it is a chemical. 10 mg for hypertension. Hypertension के लिए the value. Okay, I switch to, yes, this is again was recommended due to suspected intolerance. Intolerance is also, I should be, yes. Okay, very good. So there are two chemicals identified. Very nice. Then relationship, it is also working, and linking entities. Again, it is very good. Yes, इसने यहाँ पे relationship भी entity relationship medication, ये last statement print is also working here. Medication, this is related to this is hypertension, correct? In this sentence you can see directly the sentence is have the relationship reported the nausea, this medications, and this is the disease. The medicine name is lisinopril 10 mg for hypertension, correct? This is identify a system identified that yes, medication this is related to this is hypertension. Very nice, the results is very good. And after that, yes, these are the converted into the different entities, and the sentence is again same. So we can also try one or two datas. Otherwise, the working our models is working perfectly. Yes, Mr. Sen, have you tried?
Sir. In case of the main diseases are there, so it is creating two different lists for disease and chemical, or I think medication is also considered as chemical, right?
Yes,
Sir?
yes, medication is considered
Yeah.
as a chemical. Yes.
Yes, yes. So we are actually tokenizing the entire text, and then we are preparing the named entity recognition for that. I think two models were loaded in the first line. Those two are working for us. Yeah.
Okay, okay. In this case, they are the relationship. It is established the relationship between the medicines and the disease in the last line.
Yes.
No, it is identified these are the diseases. It is identified this is the medications, and
Yes.
it is established the relationship between medicines and disease.
Yes. Yes. Yes.
So let's try some pediatric report. Yes, pediatric case, 7 years old. Yes, let's try this one also.
Please share that actually.
Yes. Okay. So we will run clinical text first. Okay. These are the entities and these are the taggings. Done. Then, okay, there are disease. One disease, two chemicals. Let's see the relationship between them. Link. Okay, it is observed disease and medication, but the relationship is not established. Fine. Yes, it is done. So, okay, fine. I will share these different category of data. If you can search also, not necessarily we are not restricted for these examples only. You can search in Google, or you can go to generate. You can generate this type of clinical text using ChatGPT also. ChatGPT will can help you to generate this type of text, chemical text, clinical text, you can say. Correct. So there are one more we can try. Some relationship should be established. So here we are doing only tokenization, lemmatization, POS tagging we are doing here, and NER. NER is the named entity relation, recognition. After that, we are doing relationship and patterns. What are the patterns here? That's all. Here is also relationship between the disease and medications are not established. Fine. So system is working. We can go more. जैसा मैंने आपको पीपीटी में भी बताया था, there are different types. So yes, so we have done only these two things: tokenization, lemmatization, and NER. Correct. This text classifications, word embeddings, sentiment analysis. After that, the word is completed, complete sentence. We had converted into the entities. So now you can use these entities and these nodes after the parsing, after the NLP. You can use these nodes to generate the models, generate the predictions, generate the you can say some. You can use some neural network. Correct. The main purpose of natural language processing is the process the natural language data. It will be available in any language, in English, Hindi, Marathi, Bangla, or whatever, Kannada, Gujarati, whatever, जो भी हो. Correct. French, Japanese, Chinese. So clinical data can be available in any language. The purpose of natural language processing is to clean the data, process the data, tag available, process that. After processing, it will be converted into the tags, nouns, verbs, and punctuation marks. Everything need to be differentiated using the some parsing algorithms. Correct. So parsing algorithm, you can say derivation also. So every word is different. Every word is related with the which word is representing disease, which word representing is the chemical, which word is the drugs. Everything is separate out. Then you can generate some models using machine learning algorithms or deep learning algorithms, so that you can design some models to predict this kind of disease after the clinical after passing the clinical data, clinical text. So this is the basic applications of this kind of task of natural language processing. So I hope all of you understand this kind of topic. Hope all of you enjoyed. Thank you so much for listening patiently, and thank you Sen sir and Rajasmita sir to actively participate. Any doubt you can ask?
Any participants having any doubt, you can ask our expert, Dr. Animesh Dayal.
Welcome, sir. Manoj Chaudhary, sir.
Okay, sir, shall we conclude the session?
Yes, ma'am. My part is over. If anyone can ask any questions, so okay. Otherwise, thank you so much.
Okay, sir. I think our participants are fully satisfied with the session.
Great. So I can stop my screen presenting. Stop presenting.
Thank you, sir, for sharing your expertise with us. Your lecture was highly informative and helpful. It was incredibly enlightening. Thank you, sir.
Thank you, ma'am. Thank you so much.
Dear participants, with this, we come to the end of our